prepared and they can still kind of focus. So yeah, as always, we'll start with the homework. And with the first few parts, you were asked to kind of just evaluate the powers and give your answer as a final number, right, with no powers. Here, for question A, for part A, there was a very common mistake that people were making, which is that the -6², a lot of people took that to mean, they took it to mean that I was saying -6², which they're right, this is 36. But actually here you see there are no brackets between the minus and the 6. So -6² is actually just the negative of 6², which is -36. Right, so these two things you have to be careful. Right, so for the first question then, it was just -6² plus 4 times 3², which is 9. So because -6² is just -36 plus 36, here it was 0. Okay, because the minus sign only applies to the 6². The minus sign is not inside the square. Okay, so you have to be careful. For the first question, it was just -36. Now for part B, you see immediately that the minus sign is inside the bracket, which means that -2 to the 4 will just be the minus. You have to take that into account when you're raising -2 to the power of 4. So what this means then is that because it's an even power, there will be an even number of minus signs, which means each minus sign will cancel out in pairs with the other minus sign, right? Because they're an even power, there are even number of -2s. So it's the minus signs will cancel out in pairs. So here it'll be -2 to the 4 is the same as 2 to the 4, right? Which, as you might know, is 2 times 2 is 4, times 8 is times 2 is 8, and times 2 is 16. Right? So to the 16. Okay, and you can do the similar thing with the denominator. 3² is 9, 2² is 4, and you square that, so that's will be 13², which is 169. Okay, so your answer here was 13 over 169. So yeah, you could have done the similar thing with the rest. William, can you explain how you did part C?
For part C, I think I did the top. I mean, each fraction, like I squared them first.
Okay, so how do you mean?
And I got, so basically I got 1 times a quarter divided by a third times a 16th.
So 1 times a quarter divided by a third times the 16th. Yes, okay. And what do you do from here?
And then I just did the multiplications.
Yeah, so what does that give you?
A quarter over 1 over 48.
Yeah, a quarter over 1 over 48. Okay, and how do you kind of do this division with the fractions?
I remember that the numbers on the outside can like work. Numbers on the outside can like go on the top, and the numbers on the inside can go on the bottom. It's kind of like.
I mean, all right, so that is right, but you should understand why that's true, right? So, do you know how to divide fractions? How do you do a over b divided by c over d?
I mean, you flip it over.
So a over b times d over c.
Yeah.
And this gives you
AD over BC.
Okay, right. Now you see this fraction, this is the exact same thing. We're dividing a quarter by a 48th, right? So it's a quarter divided by 1 over 48, right? That's what this line tells you. So what should this be?
It's quarter times 48 over 1.
So it's 48 over 4, right?
Yeah.
So this fraction is 48 over 4, which is
12.
12. Okay, so yeah, that's a lot of people were struggling with the fractions. Is a over b divided by c over d. This is the same as a over b divided by, so let me put some brackets to make it clear, a over b divided by c over d. and this is a over b times d over c. And so AD over BC. Okay, right. So yeah, that would give you a 12. And then lastly, it was just adding the fractions, right? So here you had to use the definition of power of negative powers, which is you were also using here. A to the minus n is equal to 1 over a to the n, right? So in this case, 2 to the power minus 1, that's a half, right? Plus 4 to the power minus 1, that's 1 over 4. A half plus a quarter is 3/4, and that would be your answer. And of course, decimals were also fine if you express your answer as decimals. Okay, parts E to I, that's when things got a bit complicated with all the minus negative powers. You had to write your answer with only positive exponents, right? Meaning only positive powers. So here you see a lot of negative powers. You want to kind of get, you don't want any negative powers, so you kind of, any negative power you see, you can kind of flip it over, 1 over v to the 5, for example. So for E, Felicity, can you explain how you did it?
For E, so sorry. E, I convert, well, as it's negative, the entire bracket's minus 2, right? So
Yes.
then I got 1 over open bracket 2w to the power of 4, v to the power of minus 5, and then close bracket 2.
Yep.
Does that make sense? So then that equals 1 over, if you expand the bracket, 4w to the power of 8, and then v to the power of minus 10.
Yes.
And then I got 1 over 4 to the 4 times 4w to the power of 8 over v to the power of 10.
Yep.
And then that equals v to the power of 10 over 4w to the power of 8.
Yeah. Okay. Right. Yep. Exactly. That's great.
Thank you.
Molly, F, how did you do that?
For F,
Yep.
I didn't do that. I wasn't sure.
Okay, let's try it now. So what is the negative y to the power of minus 1? What does that mean?
Y by the power of minus 1.
Yeah, what does that mean?
Y times minus y?
No, not quite. It means 1 over y. Okay, so negative powers, it just means the reciprocal and whatever power it is. So y to the power of minus 2 would be 1 over y squared. A over b to the power of minus 3 would be b over a cubed. Right, so you reciprocate and you raise it to that power without the minus sign. Okay, so let's try with 2x to the power of 4, y to the power of minus 1. We want only positive exponents. So
I could put y at the bottom and x at the top?
Yes, so this becomes 2x to the 4 over y, right?
Yeah.
What about x to the minus 6 and y cubed?
That'll be at the top.
So can you tell me the fraction?
X by the power of 6 over y by the power of 3.
No, not quite. Look at which one's negative.
Y by the power of 3 over x by the power of minus 6.
Y cubed divided by x to the power of 6. Okay, now let's put it together. We need to do that fraction calculation. So what we do is okay. Right, so that's our thing. And okay,
so wouldn't it be be on the opposite, because minus x by the power of minus 6 s at the bottom?
Yes, okay, so all right, if you put those in, what do you get here? So this is equal to that, right?
Yeah.
So it's 2x to the power of 4 divided by y divided by y cubed over x to the power of 6. Okay,
yeah.
what do you do from here?
So it will be like 2x by the power 4
Mhm.
plus x by the power 6.
Yeah, not plus, but times, yes.
Yeah, and y plus y by the power 3, so that'll be y by the power 4.
So divided by y times y cubed. Yep,
Yeah.
right. Yep, exactly. That's it. Y to the 4. Okay, yep, that's totally fine. Just to offer kind of an alternative kind of way is that you can focus on the x's separately and the y's separately, right? So remember our rule, when you multiply by the powers with the same base number, our rule says that you must add the powers, n plus m. So clearly, well, not clearly, but at least intuitively, it makes sense that if you divide by the powers, a to the n divided by a to the m, it makes sense that because division is the opposite of addition, multiplication, you do the opposite of addition here, which is a minus m. Okay, so for multiplication, add; for division, subtract the powers, as long as your base numbers are the same. So a and a and a. Right, so we can do the same here, right? We're gonna separate out our fraction into 3 things. So I'm gonna 2 times x to the 4 divided, let me write that clear, x to the 4 divided by x to the power minus 6 times y to the power minus 1 divided by y cubed. Okay, so I'm gonna look at this separately. Now, from what I just said, I know that I need to subtract the powers, but I have to be careful with the minus signs, right? So it's gonna be x to the power 4 minus 6 times y to the power minus 1 minus 3. And this minus 1 is just from the minus 1. So then it becomes 2x to the power of 10, y to the power minus 4. And as you know, the negative power means it's reciprocal. So 2x to the power of 10 times 1 over y to the 4. And when you do this multiplication, it becomes 2x to the 10 over y to the 4. It's the same answer as before, right? So that's another way to kind of look at it. It's, of course, the method is entirely the same, but you're just looking at the factors differently. Okay, Audrey, how about G? Part G. Okay, maybe she's not there. William, part G.
For part G, I basically kind of like minus, like, it's kind of like terms, so I just got like simplified the m and the n.
Right. Okay, so it's just like what I said. You need to look at the m separately and the n's separately, right? So I think that's what you're saying. M to the minus 2 and m to the minus 7.
Yeah.
N to the minus 10 and n to the minus 3. Okay. So how do you simplify these?
I kind of like I did minus 2 plus minus 7 and minus 10 plus minus 3 because they're both negatives.
So if you're dividing, should you add or should you subtract?
Subtract, but then they're both negatives.
It doesn't matter. It's minus 2 minus 7, right?
Yeah, which is technically minus 2 plus 7.
Yeah. So what do you get? M to the power of
m to the power 5.
5 times
n to the power of minus 7.
Yeah. Okay, and writing it just as positive powers, what do you get?
M to the power of 5 over n to the power of 7.
Yeah. Okay. Right. Exactly. Yeah. And let's come back to Felicity for H, part H.
For H, okay. I got Q4 at the top.
Okay.
Over open bracket 2p to the power of 2, close bracket cubed.
Yep.
And then under that 1 over 6q p to the power of 7.
6q. Wait. So.
Oh, sorry.
6q p to the power of 7. Yep.
Yeah. And then that equals q to the power of 4 over 8p to the power of 6.
Yes.
times 6qp to the power of 7 over 1.
Yeah.
So that equals q to the power of 4, p to the power of -6 over 8.
Okay, so 6q to the power of 5, p to the power of 7, right? Because you multiply these two.
Yeah.
And divided by 8p to the 6. So what does that give?
Oh, 6qp to the power of 7.
No,
Oh no, sorry.
Yeah,
sorry. Does that equal 3 over 4 3/4?
Yeah.
Q to the power of 5.
Yes.
And then p.
Yeah, just p.
Sorry,
Okay.
I got a bit confused with the
Yeah,
set.
that's right. Okay, yeah, that's it. So yeah, you just need to be careful with the minus signs and just take it one step at a time, right? Don't try to skip steps. Last one is possibly the most messy. So Molly, how did you do part I? Molly, part I?
So I got Z. So Z by the power of minus I didn't get anything for that.
Okay, well, let's take it one step at a time then. So let's look at the insides, right? We're gonna ignore the -4 for now. We're just gonna look inside the brackets. So like I said before, right, you should collect the like kind of terms. So you see there's a Z at the top and Z at the bottom, Y at the top, Y at the bottom, X at the top, and X at the bottom, right? So we're gonna focus on each letter separately. So for Z's, what do I have? Molly, for Z's, what do I have?
So it will be -2.
So I have.
Oh, sorry. So it'll be it'll be 4.
Yeah, okay, let's do it step by step. So we have Z squared at the top, and what else do I have?
Z by the power of 6 at the bottom.
Yeah, okay, and if I divide these two, what do I get? This is equal to Z to the power of what?
4 -4.
Yeah, 2 minus 6, right? So this is Z to the power of -4. All right, let's do the same for Y. What do I have for Y?
So for Y, you would have Y by the power of -1.
Yes. Is that it?
And Y by the power of 4 at the bottom. So it would be a Y by the power of 4.
Nope. What's -1 minus 4?
-5.
Yeah. Okay, so yeah, you have to take that in the -1 into account as well. And lastly, for X, what do I have?
And X, you would have X by the power of -3 times X over X by the power of -8. So that'll be X by the power of -11.
Okay, let's be
-11.
So it's -3 minus what?
8.
Nope, -3, which comes from here.
-8.
Yes. So that is what? X to the power of?
11.
-3 minus -8.
Oh, 5. Sorry.
Yeah, this 2 minuses, that gives a plus. So -3 plus 8, which is 5. Okay, so we have all these things. We looked at it separately. If you had to put them back together, how do you put them back together?
So you put them together, like,
So what goes
so
inside the brackets with the power of -4?
x by the power of 5 goes at the top, and then z by the power of -4 times y by the power of 5 at the bottom.
Okay, I'll just write it like this for now. If you apply this -4, what do you get?
You would get x by the power of minus. Do you times it or do you plus it?
Yeah, you times them. So remember, ab to the power of n is a to the n times b to the n, and
Okay.
a to the m to the power of n. You have to use them together. Is a to the m n. And so you multiply the power.
So it will be x by the power of 20, z by the power of minus 20, and z by the power of 16, and y by the power of 20 as well.
Yeah. Okay. And if I want only positive exponents, what do I do? I don't want the minus.
You leave the z and the y at the top, and you just move x to the bottom.
Yeah. So x to the 20. Okay. Right. Yep. That's absolutely it. So there's your final answer. So yeah, these are probably most likely like the harder parts of GCSE in terms of indices, right? These are kind of the harder questions you would get in GCSE, purely on indices. Okay, William, how did you do question number 2, the part A?
For question number 2, part A, I firstly so I put them into brackets first.
How do you mean? What did you put into brackets?
The numbers, because I had to like kind of like make it all like tens, make them all tens.
Okay, right. So this is 10 to the x is already fine, right?
Yeah.
How do you change 100 to the 2x?
I made it 10 squared to 2x.
Okay, so 100 to the power of 2x is equal to 10 squared to the power of 2x. Yes. So what does this become? 10 to the power of?
10 to the power of 3.
3?
That's what one thought, yeah. And
No,
outside
I'm talking about 100 to the power of 2x.
Oh, that's just 10 squared outside 2x, isn't that?
You can simplify that further.
It's just 10 to x, 10, and then outside is x.
No, not quite. So remember, a to the power of m to the power of n is what?
Is a m plus n.
No, that happens when you multiply.
Am times itself. Am times itself n times.
So that's what final power is that?
Is this amn?
Yeah, amn. So in this case, is that not the exact same thing you have?
Yeah, so it's 10 to 2x.
No.
Look. Oh, it's 10 to 4x.
Yeah, so m is 2 and n is 2x, so it's m to the 4x. Okay, so what about the 1000 to the power of 5?
I just made it 10 cubed to the power of 5, because 10 cubed is 1000.
Okay, and applying the same kind of rule as you just did. So this is 10 cubed to the power of 5. What's that as power of 10?
That's 10 to the power of 15.
10 to the power of 15. Yep. Okay. So you said you converted it all to tens, and what did you do next?
And then I made the 10x and the 10 to power of 4x. I kind of merged it together.
So yeah, that's absolutely what you want to do. 10 to the 4x. This is equal to 10 to the 15. So how do you merge them together?
I added the like terms, which is x and x, so it's 10 to the power of 5x.
Yeah, you add the powers, so it's x plus 4x, which is 5x. And this is equal to 10 to the 15. So what does it mean about x?
So we know that 5x is kind of 15. 5x is 15.
5x is equal to 15, so x is
3.
3. Yeah, exactly. Okay, right. Yeah. So when these types of questions, you want to convert it all to the same base number, right? So here, the best number to choose is 10, because you can express 100 as a power of 10 and 1,000 also as a power of 10. Okay. Felicity, for question 2, part B, how did you do that?
So, well, okay, so I first got 5 to the power of 48 divided by x.
Yeah.
Divided by 1 over 5 to the power of 4.
Divided by 1 over 5 to the power of 4.
Equals 5 to the power of 26x. 5 to the power of 26 divided by x, sorry. Times 5 to the power of 34 divided by x.
Okay, so you've done some steps, or skipped some steps, but okay, sure.
Sorry.
No, that's all right.
So then, well then, should I do a simple one? Okay, so that would equal then 5 to the power of 4 times 5 to the power of 48 divided by x.
Yes.
Equals, not the same thing, 5 to the power of 26 divided by x times 5 to the power of 34 divided by x.
And how can you simplify this?
Well, as it's multiplication, you'd add the powers.
Yep.
But should I say the overall thing? Or?
Yeah, so what did you get if you add the powers?
Oh, you get well, it's 4 plus 48 divided by x.
Yeah, so what I mean with the powers here.
Oh, 60 divided by x.
Yeah, 60 over x. Okay, and what's your next step?
Well then, by adding them, 4 plus 48 divided by x equals 60 divided by x.
Yeah.
Then you divide 12 by x, and that equals 4. So then x equals 3.
Okay, so where did you get the 12? So you moved it to the other side, so it's 12 over x.
Yeah.
So that gives you x equals 3. Yeah.
Yeah.
Absolutely right.
Okay.
Yeah. So yeah, that's one way to do it. Another way is to collect all the 5s and just the x's together. So the right-hand side, you can write it as just 5 to the 48 over x and minus 26 over x minus 34 over x. And the left-hand side is 5 to the power minus 4. So just equate the powers. In this case, minus 4 is equal to minus 12 over x. And you should be able to see that, the number that divides 12 to give 4 is 3. Okay, and last question on Pascal's triangle. So the first part here, so first of all, you were given the Pascal's triangle. You were kind of, just as a reminder. Then there for part A, I say that using Pascal's triangle, I can see that the expansion of x plus y cubed is that. And notice I didn't multiply out the brackets. I just got the answer somehow. And the question was, how did I get it? So Molly, how did I get this expansion without multiplying everything out?
So wait, is it, do you want B?
For A, part A.
So you could use the Pascal triangle to do it.
Yeah, so exactly how did I do it?
So x, so 1x by the power cubed plus 3x squared y.
Yeah, okay.
Plus 3.
Yes, you are right, but so first of all, how did I get these numbers that I've highlighted in red? Where do they come from?
The Pascal's triangle.
Specifically where? Which row?
The third row.
It's the 4th row, but yeah, sure, it's the n equals 3 row, right? So
Yeah.
yeah, this is the first, second, third, fourth, but yeah, okay, so it's the n equals third row. And okay, so that's fine. The coefficients 1, 3, 3, 1. So that's from the n equals 3 row. What is the pattern with the powers of x and y? What's the pattern there? What's happening as you go from left to right?
It goes to 1, 3, 3, 1.
Yeah, those are the coefficients. I'm talking about the terms with the x cubed, x squared y, x y squared, y cubed. What's the pattern as you go from left to right?
It goes up and then it goes down and then down.
What goes down?
The power for x.
Yes.
And the power of y, they go up.
Right. Okay. So it goes down how much?
By 1.
Right. So it decreases, and at the same time, the power of y increases. Right. So that's how I work
Yeah.
the expansion of x plus y cubed without multiplying everything out. Remember, x plus y cubed is the same as saying I multiply by x plus y 3 times. So x plus y times x plus y times x plus y. Right. So of course, this is going to be a real mess and a bit of a headache to kind of work out everything, right? Because first I have to do this bracket, I have to multiply everything out here. Then I have to collect everything, collect all the like terms, and then multiply again with the last x plus y. So it's just going to be a mess. So that's why we use Pascal's triangle, right, to save on all the hassle. So for part B, Audrey, how do you expand a plus b to the power of 7?
Do you do a7 plus b7?
Okay, so a common mistake, just let me say it again, a plus b squared does not equal a squared plus b squared, right? People say that's a lot, but that's not true. You can just work it out. If you put in values for a and b, put any values for a and b, and you'll see it doesn't necessarily work. So 2 plus 1 squared is not equal to 2 squared plus 1 squared, because look at this. This is 3 squared, which is 9. This is 4 plus 1, which is 5. These are not equal, right? So that's not true. And neither is it true for the power of 7. A plus b to the power of 7 is not just a to the 7 plus b to the 7. If it was that simple, I don't think I would have made you work through Pascal's triangle to get the answer, right? So think about what which I just talked about with Molly, with how the powers work and where the coefficients come from. If I want the power of 7, which row should I look at?
Would you look at the second row?
Why the second?
Because the third row.
Why the third one?
Because there's like 6 in there, and 6 is, I'm not too sure.
Okay, so you need to, whatever the power is, that's the row you need to look at, which in this case, you want to look at the n equals 7 row. Okay, so first of all, let's get the n equals 6 row, because then you can work out the n equals 7 row. How do you get the n equals 6 row from the triangle here?
On the third row.
What do you mean?
Like in the middle where it says 6.
No, that's not how it works. So these numbers I can get them from above. Okay, so if you look at this, 5 is 1 plus 4, 10 is 4 plus 6, 10 is 6 plus 4, 5 is 4 plus 1, 6 is 3 plus 3, 4 is 3 plus 1, 4 is 1 plus 3. Do you see the pattern?
Yeah.
Okay, so how do I get the n equals 6 row? It's always going to end and start with 1. So it's going to be a 1 on here and 1 on here. What goes in the middle?
5. No, yeah.
So 1 and 5.
Yeah. And
So I mean, what's the number if you add them up?
6.
Yes. Next number?
15.
15. Next number?
20.
20 and
15.
Yep.
And 6.
Okay. Now, because I'm looking at the power of 7, I want the n equals 7 rows. So I need to do one more. So it starts in 1 and ends in 1. What goes in the middle?
7.
7.
21.
21.
35.
35.
35.
Yep.
21.
7.
7.
Yeah. Okay. So it's very symmetric. 35. Okay. So now I can finally use this to work out the expansion of a plus b to the power of 7. So to do that, I use the Pascal's triangle and I look at the n equals 7 row. So what's my first term? So I know the coefficient would be 1. 1 of what?
1 of
So let's start with a to the power of 7. Okay, so it's going to be a to the power of 7. Plus, what's my next number?
b to the power of 7.
Nope, it's this number comes down. 7
to the power of 7.
Nope. The power of a goes down, 6, and the power of b goes up. Right now, this is b to the 0, which is equal to 1, so I don't write it out. What's my next power of b? So right now, this is b to the power of 0. What's my next power of b?
1.
Yeah, so this is just b to the power of 1. But again, we don't write b to the power of 1, right? We just write b. And we don't write b to the power of 0 because that's equal to 1. Okay, next, what's my coefficient? By coefficient, I mean the number in front of the letters.
Would it 21?
21. And what are my letters?
A to the power of 2.
Well, no, look at what happened.
To the power of 5.
Yep, and b to the power of
2.
Yes, next.
35 to the power of a.
No.
Well, not to the
A to the power of
4.
Yes.
And then b to the power of 3.
Yeah. Okay, next.
4 to the power of 4.
No, you need to tell me the number first, the coefficient.
21.
There's 2.
35. And then a to the power of 3. And then b to the power of 4.
Yep. Next.
21. And then a to the power of 2. And then b to the power of 5.
Okay.
And then 7 and a to the power just a, and then b to the power of 6.
Okay, and last term.
And then 1 and b 7.
B to the power 7. Yeah. Okay. Exactly. That's the pattern behind Pascal's triangle, right? It tells you how to expand the brackets without having to do it manually by hand, right? All the little terms. Right.
Yeah.
Okay. Lastly, we were asked to expand a minus b to the power of 4. So William, which row will you look at when you're expanding this?
On the n equals 4.
Right. And how do you use that row to work out a minus b to the power of 4?
Because that row you can know the coefficients.
Yes. So first, let's expand a plus b to the power of 4. Okay. Can you tell me what is the expansion here?
It's a to the power of 4 minus 4a cubed.
No, I mean just for a plus b.
A plus b. It's 1a to the power of 4 4 and 1a to the power 4. 4 plus 4a to the power 3. B to
Yes.
b, and then plus 6a squared b squared
Yep.
plus 4a b cubed.
Yep.
Plus b to the power 4.
Right. Okay. Yep. Absolutely. Okay. So how do I use that to expand a minus b to the power 4? What changes and what stays the same?
Some things turn negative.
And how do you tell which becomes negative?
I think it's anything that's multiplied by minus b, but that isn't minus b.
Oh, nope, that's a mess. So you mean
It'd be like, for example, a times minus b. That'll be negative.
okay, so look at the left-hand side. What has changed between the left-hand side of the top and the bottom?
Only the b is negative.
So b has turned to negative b, right? So in order to convert the right-hand side also, I must replace the b with the negative b. Or rather, I must replace the plus b, which is the same as b, to negative b.
Yeah.
Okay, so this is my plan. In order to convert the left-hand side to a plus b to a minus b, I need to replace b with minus b. And because the left-hand side is equal to the right-hand side, I have to do the same on the right-hand side. So what are my terms going to be?
It's still a to the power 4.
Yes, that's unchanged.
And then next is it minus 4a cubed b?
Yeah, because this plus b becomes a negative b. So minus 4a cubed b. Next.
Is it next minus 6a squared b?
No, because remember, right? B squared, I turned that into minus b squared. This is still the same as before.
Oh, it's plus 6a squared b squared.
Yes.
Minus 4ab cubed.
Okay, how do you know that b cubed will be negative?
Is it because it's an odd number?
Yeah, it's an odd power, right? So if you have minus b cubed, this will just be minus b cubed, like that. Okay, and last term?
B to the power 4.
Right.
Plus b to the power 4.
Yeah, this is still positive because it's an even power. Okay, yep, that's right. Here it is. All right, so just a quick recap of some of the stuff we've been looking at previously. So we had the classic mistake earlier about a plus b squared being a squared plus b squared. This is not true, right? The true formula is this one. This symbol, in case you're confused, is saying a plus or minus b, plus or minus b. They shouldn't really touch, but that's how it came out here. And so this is what it means, right? So this formula is saying two things at the same time. It's saying if you have a plus between a and b, your answer will be a squared plus 2a times b plus b squared. And if you have a negative between a and b, then it's going to be a squared minus 2ab plus b squared. Okay, so the a squared stays the same, the plus b squared stays the same, but if you have a plus or minus, the middle term will also change to plus or minus. So if you have a plus, it stays a plus. If you have a minus, it stays a minus. But in either case, a plus b squared is not equal to a squared plus b squared, right? There's this middle term, 2av. And we also had the difference of two squares formula. Okay, we were kind of, if you have a squared minus b squared, you can always factorize it into a plus b times a minus b. Okay, and of course we have the Pascal's triangle. Hopefully everybody understands how to gain or get the next kind of terms, right? So you just add the top two to get the next one. Okay, we're going to skip that. Right, so in algebra, you're frequently asked to solve these equations, right? When we say solve these equations, or solve this equation, or solve whatever, you're asked to find the unknown, right? In algebra, you have all these letters, and all these letters are just things you don't know yet, right? They are just they just represent numbers that you would like to find out, but you don't know yet. So in this case, you have G, So William, how would you solve equation A?
For equation A, I think I would add the g's together.
Add the g's together. How do you mean add them? Like 8 plus 5?
I would make it 13g. Is that okay? Does that still work?
Okay, if you want to add add 5g to both sides, here's how it's going to go, right? So the key principle of algebra is that because the left-hand side and the right-hand side are equal to each other, you can do anything you want, any mathematical thing you want to the side, and you have to do the same thing to the other side.
I know what to do. We can add 5 to both sides.
So 8g minus 5. So you mean plus 5 to both sides? Okay, plus 5 to both sides. What does that give me?
So 8g equals 5g plus 40.
Plus.
I mean 35.
No, try again.
I mean 45.
Yep.
And now we know that 3g is 45.
How do you know that 3g is 45?
Because 5g plus 45 is 8g's, and then 8g minus 5g is 3g.
Okay, so now you're subtracting both sides by 5g. So this 5g will cancel out with this 5g, right? So, and 8 minus 5 is 3g. This is 45. So finally, what is g equal to?
G is 15.
G is 15. Yeah. Okay. So that's the idea. You can do anything you want to either side as long as you do it to the other side also, right? It's only by doing the same thing on both sides do you preserve the equality, right? You keep the equation equal to each other, left-hand side and right-hand side equal to each other only if you do the same thing on both sides, right? That's the main idea behind algebra, or solving algebraic equations. So Felicity, for B, how do you proceed?
Sorry. The first step, I would add 4d to both sides. So then that would be 23 equals 7d plus 2.
Yes.
And then I'd take away 2 from both sides.
Sure.
So then you get 21 equals 7d.
Yes.
And then so divide by 7, so d equals 3.
Yeah. Okay. 7 times 3 is 21. So yeah, d equals
Yes.
3. Okay. Molly, for C.
So you minus 0.5x from both sides.
Okay, so what do I get on the left-hand side after you do that?
You would get 0.9.
0.9 by itself?
X.
0.9x, yes.
And then you would minus 22.1.
Okay, so what does it give on the right-hand side?
So you'll be 3.6.
3.6, okay.
And then x would be 0.4. Sorry, 4.
Yeah, x is 4, right. If that's a bit too much, then you can multiply both sides by 10 if you want, right? Just to get decimal places. So that'll give you 9x is equal to 36. So it's clear now that x is equal to 4. Right. Audrey, for part D, how do you do it? How do you find y? Okay, maybe she's gone. William, part D.
For part D, I would add 3/4 of y to each side.
So what does that leave me with on the left-hand side?
5.
What does it equal?
Equals 1.5 minus half of y.
Okay, so let's not skip steps. So minus 1/4 y plus 3/4 y, right?
Oh yeah, it's that's half of y, isn't it? Half of y.
So a 1.5. So is it plus or minus a half of a y?
Plus.
Yeah, so it's minus 1/4 plus 3/4, so that's 2/4. So it's plus half of a y. Okay, and next.
And next, we know that 5 is. I think I would add half a y. Or is that too complicated?
You can do anything you want, but I don't think it'll.
Okay.
You add half to. You get this.
Oh yeah, no, we minus 1.5.
Okay, you add 1.5. Okay, what do you get on the left-hand side if you do that?
We do 5 minus 1. We got 5 minus 1.5.
5 minus 1.5. So this is equal to half y.
Yeah.
And what's 5 minus a half? 1.5.
5 minus 1.5 is 3.5.
Yeah, 3.5. Like that. And then so what is y equal to?
Y is 7.
Y is 7. Yeah. Okay. Right. 5 minus 1.5. Yeah, that is 3.5. Yeah. So I think actually I wrote the answer wrong for that one. So g is 15, d is 3, x is 4. For some reason I wrote y equals 9. It should be 7. Okay, in this case, what would you do, Felicity, to find x?
I would times both sides by 3.
Okay, what does that leave me with on the left-hand side?
So on the left-hand side, that would be x minus 1 equals 15.
X minus 1 is 15, so that means x is?
X equals 16.
Yeah, okay. Right, so fairly okay. Molly, what about here? How would you find r? Okay, Molly's gone somewhere. William?
Oh, sorry.
Oh, okay. Yeah, how do you find r?
So you divide it by 3, so it will be r minus 5 equals 8.
Okay, r
and
minus
then you
5 equals
plus 5.
So r equals?
So and then you plus 5, so it will be r equals 13.
Yeah, okay, easy. Oh, right. And what about something like this, William? How would you find k here in this kind of scenario?
For this kind of scenario, I think let me take a look. I think I'll make the bottom fractions first, so that like the bottom fractions are like the same.
Okay, how would you do that?
Actually, would that make it worse?
Yeah, I don't think you can make the bottom numbers the same, because if you have to do the same thing to both sides, right?
Okay, then I can either multiply it by 3 or 5.
Okay, let's multiply by 3. What happens if you multiply by 3?
I have 3k.
So on the right hand side, what do you get?
K minus 2.
Yeah, by itself. On the left hand side, what do you get?
I would get multiplied by 3. Is it 3k minus 21?
Let's not multiply it out. So let's just leave it like this.
Okay.
Over 5, right?
Yeah.
And again, now the fraction is a bit annoying. So how can I get rid of that 5?
Oh, well, I have to multiply it by 5.
Okay, yeah, exactly. So on the left hand side, what do I have?
We have 5k minus 10.
Left hand side?
The left hand side, 3 brackets k minus 7.
So yeah, now we can multiply it out because it's cleaner.
That's 3k minus 21.
And on the right hand side?
5k minus 10.
Yep. And can you solve it now?
I would first add 21 to each side.
So add 21. Okay. So 3k equals?
Equals 5k plus 11.
That's 11. Okay.
And then that 2k, 3k, 5k plus 11. Then we know that 2k must be negative something.
Okay. Right, let me move that here. So 2k is equal to?
Minus.
All right.
Minus
How about? Yeah. So if you're confused, how about you subtract 5k from both sides? What do you get?
Okay. I would get minus 2k.
Yes.
Equals 11.
right? So k equals
-7.
minus what?
Minus 5.5.
Yeah, minus 11/2 or minus 5.5. Okay, yep, that's right. Okay, so algebra is a bit more versatile than that. You can even kind of deal with stuff like this where you have a square root of x. So the key here is not to worry about the square root until the end, right? So Felicity, can you try it here?
Okay. So, okay, for the left-hand side, would you just add 2 to both sides? So then it will be
Sure.
3. Yeah, so 3 square root of x equals 32 minus square root of x.
Yep.
Sorry, I'm not really sure what to do next.
So you're trying to find x, right? So the idea is still simple, still the same. So what should you do with this minus root x?
Well, you would square it.
Well, you should gather all the like terms first, right?
Oh, right. Sorry. So then you'd add the square root of x to both sides.
Yeah. So what do you get on the left side?
4 square root of x equals 32.
Yeah.
Oh, okay. So then the square root of x equals 8.
So
x equals 64.
Yeah. Okay. Yeah.
Okay.
So the idea is still the same. It's you still want to collect all the like terms on one side and collect all the other numbers on the right hand side and then do whatever it takes to find x by itself.
Okay, thank you.
Right. Okay. So yeah, the idea still the same. Just move all the x's to one side and all the other numbers to the other side, and then just rearrange to kind of get to where you want to be. So here, Molly, let's try this one. So don't worry about the fraction of the x yet. So let's just move all the x's to one side and all the numbers to the other side, right? So how would you do this?
So you can add 2 and -7 to both sides.
2 and subtract 7 from both sides?
Yeah.
So what do you get on the left side?
It will be 3 over x minus 7 equals to 2 plus 2 over x.
Okay.
And then you would move the 2 to the other side.
So you want to move it again because you already started with the 2 on the other side.
Oh, so
let me just tell you that you want all the unknowns, in this case x, on one side and everything else on the other side. Okay, so
okay.
you wanna either move the 3x to one side like this to get it together with the 2x or 2 over x, or you want to move the 2 over x to the 3 over x. Right? So which one do you want to do?
I can move it all to the right side.
So okay, I'll just say, so let's subtract 2 over x from both sides, okay?
Okay.
So what does that give me on the left hand side?
So it will be 1 over x minus 2 equals to 7.
Yep. Do you know what to do next?
And then you could plus 2.
Yes, so 1 over x equals?
9.
Okay, so finally, how do you find x?
I'm not sure.
Okay, so this fraction is annoying, right? So let's get rid of that by multiplying by x both sides. What do I get on the left and on the right?
You'll get x over x equals
Which is
9x.
X over x is what? What number is that x over x?
1.
Yep, so and 9x. So 1 is equal to 9x, right?
Yeah, so
x equals
9.
So
1/9.
1/9. Yeah, good. Okay. Right. So those are just some examples of how to solve equations, right? Even when looks a bit messy, you can still do it. Okay. So thank you everyone for your attention. I will see you next week.